Hello lovelies, in this video the brilliant Mr. B is going to be looking at integration. Now this is the first of many videos on integration, so look at the playlist to see which ones comes next. There are lots of examples, and in an exam situation you're probably going to need to be pulling things from different skill sets and putting them together in one question. If you want to see how well you can do with this sort of question in an exam, then over my website there are lots of predicted and practice papers for you to download straight away.
We are going to look at integration, which is the opposite of differentiation. And so to understand integration, we'll need to look at differentiation first. So let's say we have the question, y is equal to 6x, and we differentiate it, so we get dy by dx. And we know that when we differentiate, if we have 6x, that's practically meaning 6x to the power of 1. So to differentiate, we do the 1 times the 6, multiply the power by the coefficient, which gives us 6 still. And then we reduce the power by 1. So x to the power of 1 becomes x to the power of 0. And if you have x to the power of 0, if you think about your laws of indices, anything to the power of 0 is 1. So practically we have 6 times 1, which is 6. So what happens is the x actually goes away altogether. So if you differentiate 6x, you get 6. So coming back to integration, if you integrate 6, and then there's a few extra bits to this. We've got the integral symbol, which is kind of curly F shape, curly S shape. And then we've got the dx at the end. So these kind of show us it's an integration question. So the important thing for us here is just a 6. So if you integrate 6, then you get 6x. Because you can see the other way around, if you differentiate 6x, you get 6. So at this point you might be thinking, well, job done, it's just 6x. So there's nothing else to do. That's going to be our final answer. However, there's something else to consider here before we move on. Now, what if we differentiated y is equal to 6x plus 3? So the differential, dy by dx, we know that 6x differentiates to 6, but what does 3 differentiate to? Now again, we think about what you do here. We multiply the power on the x, and it's hidden, it's a 1. Then you multiply it by the coefficient at the start of the x, in this case it's a 6, 1 times 6. So what do we do with a 3? Well, with a 3, x is actually to the power of 0, because as we saw before, x to the power of 0 is 1. Anything to the power of 0 is 1, using laws of indices. And so 3x to the power of 0 is the same as 3. So when we do that multiplication, we multiply the power by the coefficient, then 3 times 0 gives us 0. And then we can reduce the power by 1, so x to the power of 0 becomes x to the power of negative 1, for example. But because we've got a 0 at the front, we've got 0 lots of it, so really the power on the x doesn't matter. And we don't write down plus 0. So what happens is, if we get 6x plus 3, and we differentiate it, with the hidden information in mind, the x to the power of 1, the 3 to the power of x to the power of 0, with all that hidden information in mind, we're differentiating to 6. And that's the same answer we got before. Now that's got an implication for when you integrate and do the opposite, because for all we know, when we work backwards, there could have been a plus 3 on the end. So how do we know if it's a plus 3, like our second example, or if it's not a plus 3, like our first example? You could even have y equals 6x plus 99. If you differentiate it, that's going to give you 6. Because the 99, even though it's a larger number, it's going to be multiplied by the power on the x. And there is no x, it's going to be multiplied by 0, and it's going to go away. So there's no way of knowing if it's plus 3, plus 99, or if it's plus 0 and there's nothing there. So we have to admit to this. And what we have to do, when we integrate, it's got a plus c on the end. We say it's plus a constant. There's going to be a number added on at the end. And we don't know what it is. Working backwards, there's no way to know. And that plus c could be a 0, but it could be a plus 3, it could be a plus 99, it could be anything else, it could be a negative number. It could be anything as long as it's not got an x on there. So integration, it's the opposite of differentiation, but you can't do it perfectly. You have to have a plus c on the end to admit to we can't quite get back to our original number. For our next question, we've got the integral of 2x dx. The first thing to do is just kind of highlight the integral notation because we're not going to be using this. We know it's the integration question now, so we don't need the integral symbol or the dx at the end. So we're just concentrating on the 2x. Now again, kind of working backwards and look at differentiation. If we had y is equal to x squared, then differentiating it, multiply the power by the coefficient. If there's no coefficient, it's 1x squared. So 2 times 1 is 2. Reduce the power by 1, and we have 2x. So we know the answer to the integral of 2x will be x squared. We're just going in the opposite direction. And remember, if it was y equals x squared plus 1, that would still differentiate to 2x because the 1 would go away. So we can't guarantee there was no more kind of extra numbers on the end. So we've got to write a plus c, saying that we might have a number at the end, a constant. So that's our answer, x squared plus c. Of course, we can't just rely on guessing what the kind of differential version of this is and then kind of working backwards. So we need a method to integrate. So this is the method. If you have an x, let's say we've got ax, the power of b. If you integrate that, this is what happens. Firstly, the power is going to increase by 1. So we're calling the power b, then our new power will be b plus 1. So the power goes up. It's like in differentiation, the power goes down. So you have 2x, and there's no power, so it's power 1. 2x to the power 1 has become x squared. Power 1 has become power 2. You can also see that the coefficient at the start, the a, that's changed as well. And what happens is you take the coefficient from the a and you divide it by the new power. So in our question, we've got 2 as our coefficient, that's a. And that's going to be divided by the new power, which is 2. And 2 divided by 2 is 1, which is why there's no coefficient on our answer. It's 1x squared. So this is the kind of general formula for integration. Increase the power by 1 and divide the integral by the new power. Just like in differentiation, you multiply the coefficient by the power. So it's kind of doing the opposite. So moving on to our next question, we're going to do this without thinking about differentiation and thinking about the general form I just looked at. If you want to integrate something, so let's call it ax to the power of b, then that's going to be equal to the power increasing by 1 and the coefficient being divided by the new power. So let's look at our question. So we've got the integral sign, we've got the dx at the end. So we're not going to focus on those. They just tell us it's an integration question. We need to look at the power first. So we've got x to the power of half. We need to add 1 to that. That's going to be x to the power of 1.5. And you could write 1.5 as a fraction or a decimal for this. A decimal might be better for the next bit because then we're going to take the coefficient, 6, and we're dividing it by the new power, 1.5. Now, we can actually do 6 divided by 1.5. You can think, well, how many 1.5s fit into 6? And you can fit 4 1.5s into 6. 2 of them's 3, so you need another 2 after that. So 6 divided by 1.5 is 4, and we've got x to the power of 1.5. So perhaps when you think about writing it as a decimal in your working out, and then you can write it as a fraction in your final answer. But it doesn't make too much difference which way you write it. Just some forms look better for answers, and some are better for your working out. Now, at the end, remember, it's really important you need to put the plus c. The plus c is really important because there could have been another number on this, but going backwards compared to differentiation, it's impossible to tell what that would be. For the next question, we've got the integral symbol and the dx telling us it's an integration question. So we're working with the cube root of x squared. Now, the first thing to do is rearrange this into a form which makes more sense with the kind of general rule that we've got. What we want to do here is kind of get rid of the root symbol and turn it into a index. So we've got the x squared, and if you do the cube root of it, that just means that you put over 3 on your power. So with our new power, we've got fractional indices here. The power on the x is the numerator, and the root is the denominator. So the cube root of x squared is the same as x to the power of 2/3. And now we've just got it written as a number and not any kind of symbols. Now we can use our method. So we're going to take x and we are going to increase the power by 1. So 2/3 becomes 1 and 2/3. Then we have the coefficient on the x. Now there isn't a coefficient if there isn't a coefficient, it's 1, and it's being divided by the 1 and 2/3, which is 1.6 recurring. So it might be a little bit better to write it as a decimal. Now we have to work out 1 over 1.6 recurring. There's a few methods of doing this. So the first method is you use a calculator to deal with this for you. Another method is to think, well, actually, 1 and 2/3 is the same as 5/3. A whole one is 3/3. Then we've got the 2/3. So we're doing 1 over 5 over 3. Now, if you get this kind of triple decker fraction, it's really bad. We shouldn't be allowed to do this. Maybe put brackets around to show that this is the denominator. But if you get a 1 over a fraction, that's telling you to take the reciprocal. And so you can just flip the fraction upside down. So 1 over 5/3 is equal to 3/5. And so you might well see with this that actually working with it as a fraction was easier if you're good at your fraction skills. Whereas if you had a calculator with you, then you could do 1 divided by 1.6 recurring, and that would also get you 3/5, perhaps written as a decimal, perhaps 0.6. But you would get the same answer. So just be aware of the different ways you can use to work with these and which kind of transformations are useful. So for example, mixed numbers being proper fractions, top-heavy fractions, and you're working out, seems like it's beneficial. Once you've got the answer, you might want to turn it back into 1 and 2/3. That's fine. It might be the question's asking for a specific format. If it's not asking for a specific format, then either one of those answers should be good enough. One thing I've forgotten here, I've had to go back and edit this video, is we've got to put the plus C on. It's really easy to forget it. So that's why I'm admitting that I did forget as well, because it's just so easy to forget about it. Make sure you always write your plus C. For our last easy question, again, we have the integral symbol and the x. So we're looking at 3 over x to the power of 4. And again, for this one, our first step is changing 3 over x to the power of 4 into a usable format for our general rule. We want to get rid of any fraction, any kind of other symbols. So we could write that as 3x to the power of -4. So if you've got an x kind of value on the denominator, you can bring it up to the numerator if you make the power negative. And so that's what we're going to be integrating. So now we follow our rule. We'll take the power. It's x to the power of -4. We need to increase it by 1. It's going to be -3. Then the coefficient on the x of 3, that's going to be divided by our new power, which is -3. We can do 3 divided by -3. It's going to give us -1. So we can write -1x to the power of -3. Now, again, that should be fine as an answer, but you can always turn it back into its original form. So that's actually the same as saying -1 over x to the power of 3. And we're just using the same thing we used before, where if you have a x on the denominator, you can bring it up to the numerator by making it negative. Well, that process works in reverse as well. And if you've got a negative power, you can write it as a denominator under 1, as long as you make it positive, or rather, you flip the sign. Then at the end, as usual, add in the plus C. Moving on to the medium questions, we've got a few new things. The first thing is we've got some different notation. So another way to write an integral is to write you've got f dash x. So the dash means you've got a kind of differentiated function. And we want to go back to the original function. So you might see it written like this. Now, if you integrate 2x, we've done this before, it's going to give you x squared. We've increased the power by 1. Then we divide the 2 by the new power. 2 divided by 2 is 1. So we've got our answer straight away. It's really easy. This brings us to the second new thing. We've got the coordinate 3, 6. Now, that is all about, so far, we've been writing plus C when we've been integrating, because we know there's multiple different things you can differentiate to x squared. And so there could be plus a number at the end. Now, it's not going to be an x term. It's not going to be x cubed or x. It's just going to be a number, 1, 2, 3, maybe even a fraction, a decimal. Now, using the coordinate, we can actually work out what that plus C is going to be. Now, we've got x and y coordinates. X is 3 and y is 6. So we just substitute. So y is 6, x is 3, and we're adding on C. That's going to give us that 6 is equal to 3 squared, which is 9 plus C. Then we can take 9 away from both sides. 6 take away 9 is -3. So that means that C is going to be equal to -3. So now we can write the true answer. F of x is equal to x squared minus 3. So the plus c, it was a negative 3. And we'll just substitute that in at the end for our final answer. So we're going to see now for the medium questions, you can actually work out what the c is if you have additional information. For example, a coordinate. So moving on to the next question, we have two things to do. The first thing is to integrate. So if f dash x is equal to 8x squared, then f of x, follow our integration method, we're going to increase the power by 1, x squared becomes x cubed, and we are going to divide the coefficient by the new power. So 8 will be divided by 3. And without any other information, we need the plus c. Now we've got this, our second step is to look at the coordinate and to use the coordinate to work out what the plus c is going to be. So if we think about putting this in the form y equals mx plus c, we can have y is equal to 8/3 x cubed plus c, and we can substitute in the 1 and the 1 from the coordinate. 1 for x and 1 for y. That would give us 1 is equal to 8/3 multiplied by 1 cubed plus c. Now, 1 cubed is a nice easy one because anything, with a 1 is going to end up with a 1. So 1 cubed is 1. And then that's been multiplied by the 8/3 to give us 1 is equal to 8/3 plus c. So we want to take 8/3 away from both sides. It might be useful to think about 1 as being 3/3. So 3/3 take away 8/3 would be negative 5/3. And now we have our value for c. And now we can go back and write that in to our original answer. So f of x is equal to 8/3 x to the power 3 take away 5/3. And so now we've gotten rid of the plus c and we find the value of it, negative 5/3. A next step might be putting these into mixed numbers. So 8 divided by 3 would be 2 remainder 2. Put the remainder over the fraction. And 5 divided by 3 is 1 remainder 2 over the denominator. Now, in either one of those two forms should be absolutely fine for a final answer. It just might be that he has to write it in a mixed number for a next step, for example. So just be aware that that's something you can do. For the next example, we're going to start having some fractional indices in here again. So we want to find what a function of x is. And we've got the differentiated function of x above. So we take the x is to a half. So we increase that by 1, x is going to be to 1.5. And then we need to divide the coefficient on the x by the new fraction, which is going to be 1.5. Now, again, not the nicest fraction to have something like that, so let's try and rewrite it to be something a little bit more useful. So we could have, for example, 2 over 1.5. 1 is 2 halves, so altogether that's going to be 3 halves. So we could write it out like this. And something we can do here is we can bring the denominator up. It's very much like when you have a x to the power of something on the denominator, and you bring it up to the top and it becomes a negative power. You're kind of like taking the reciprocal of it. And we're going to do that with the fractions. 3 over 2 is going to become 2 over 3. So we can write it like this. And we multiply 2 over 3 by 2. That's going to give us 4/3. So now we've got 4/3 x to the power of 3 halves. So we just very carefully try to untangle these fractions to get them all combined together. Another option for these, if you do have a calculator, is you can just type 2 divided by 1.5 into your calculator, and that's going to give you the same answer. So that's step 1 done. We integrate it. Step 2 is to work out what the plus c is. And again, we're going to use the coordinate we're given as a clue. And we have an x part of the coordinate, 1, and a y part of the coordinate, 5. So altogether, we're going to have y equals 4/3 of x to the power of 3 halves plus c. So we know that y is 5. We know that x is 1. Now, 1 to the power of anything is going to give us 1, so that's fine. So it's going to be 5 is equal to 4/3 plus c. Might be helpful to think about 5 in terms of thirds. A whole one is 3/3, so 5 will be 5 times bigger. It's going to be 15/3. So take 4/3 away from both sides, and we're going to have 11/3 is equal to c. So now we can write down our final answer. Function of x is equal to 4/3 x to the power of 3 halves plus 11/3. All that's left now, you might want to turn some of these into mixed numbers. So 4 divided by 3 is going to be 1 1/3, 1 remainder 1. 3/2, 3 divided by 2 is 1 remainder 1, so 1.5. And then 11 divided by 3 is going to be 3 remainder 2, so 3 2/3. But again, either one of those two forms should be fine for your final answer. Our next question is f-x is equal to 4/x to the power of 9, and we want to integrate and find f of x. The first thing to do though is look at f-x and get it into a more usable format. We can write it as 4 lots of x to the power of -9. Again, we can turn a denominator with an x into kind of a numerator if we make the power negative. So now we can integrate. So we're going to take our power, x to the -9, and increase it by 1, to x to -8. And we're going to divide our coefficient 4 by the new power, -8. 4/8 is going to give us a half, so it's going to be a -half of x to the power of -8. And of course, it's going to be plus c. And that plus c is our next step. We need to figure out what that number is. So we're going to use the coordinates, x is 7 and y is 5. So we're going to have y is equal to a half x to the power of -8 plus c. So the substitute, that'll be 5 is equal to a -half multiplied by 7 to the power of -8 plus c. So we need to work out a few things here. So 7 to the power of -8 is something you work out on your calculator, and we can multiply it by a -half. And on my calculator, I'm actually getting something quite complicated. -8.67 times 10 to the -8. So perhaps we don't want to do it that way. So an alternative might be to change this back into a fraction. So we could have 5 is equal to -1/2 multiplied by, so a -8 could be written as 1/7 to the power of a +8. Now, 7 to the power of 8 on your calculator, actually we can get a number out of this. So it's going to give us 5 is equal to -1/2 multiplied by 1/5,764,801. And so we times that by a -half, there we're actually going to double that denominator and make it negative. So 5 is going to be equal to -1/11,569,602. And we're going to take that away from 5. Now, I think you can probably tell here that's a pretty ridiculous number. So we can just say that 5 is equal to c. Because really, if you think about it, it's such a small number, and next it'll be adding that to both sides, only going to be slightly above 5. So while we could continue with this, if you're going to round your answer to even quite a few decimal places, you're going to end up with 5. So for a final answer, we can write f of x is going to be equal to -1/2 x to -8 plus 5. Again, remember we rounded that. Then your last step might be that you just want to turn the x to the power of -8 into a fraction again. So you'd have -1/2 x to the power of -8 would become 1/x to the power of +8. Then you can multiply those two fractions together, and you can get 1/2x to the power of 8 plus 5. Another way you can change the form of this is just swap them around and write the 5 first, and then that way you don't have to write the plus sign. And again, the purpose with this is the top answer is perfectly fine, and you will get full marks for the top answer in most cases. The rearrangements I'm showing you below are just options if you do something else next, or if it's asked for the answer in a specific form. Moving on to our last medium question. So f-x is not quite in the form we want here. It's 6 over the square root of x to the power of 4. The first thing is let's deal with the square root. So the power is going to be the numerator of the fractional index, and the root will be the denominator. So it's going to be x to the power of 4 divided by 2. And we can do 4 divided by 2. It's going to give us 2. Next, we can bring the x squared up to the top by making it a negative power. So now we've got something usable, and now we can integrate. So to integrate, we're going to increase the power by 1. X to negative 2 will become x to negative 1. And we're going to divide the coefficient by the new power, negative 1. 6 divided by negative 1 is going to give us negative 6. And we've got the x to the power of negative 1. Remembering it's plus c. And we have to find the c because we've been given a coordinate as a clue to find it. With x being 3 and y being 8. So if we say that y is equal to negative 6x to minus 1 plus c, well, y is 8, x is 3, and we can start to work this out now. We might want to rewrite it, so we've got the negative 6 is being multiplied by 1 over 3, because that's the same as 3 to the power of negative 1. That means that 8 is equal to negative 6 thirds plus c. Lots of little bits to work out here. 6 divided by 3 is 2, so 8 is equal to negative 2 plus c. When we add 2 to both sides, we're going to get that c is 10. So again, we can write down our final answer. F of x is equal to negative 6x to minus 1 plus 10. Now again, we might want to rearrange this in various ways. So we could write that it's equal to, so we can make x to the minus 1 be 1 over x. That'll be minus 6 times 1 over x. And that's going to give us a negative 6 over x plus 10. And again, another option, put it the other way around so you don't have to write a plus. So again, our first answer should be fine for most questions, but you do have options to change it back into a fraction if you wish. The hard questions are going to get to the heart of what integration actually means. Now, to start off, we're going to have a look at our question, and we can see we've got the integral symbol, and there's a couple of extra numbers on it, so we have to keep these in mind. We've got a 3 and a 0, and then we've got the dx at the end. So we are integrating the 4. So we use our rules we've been using, so we're going to increase the power on the x by 1, and if there's no x, then you can include an x. And then you're going to divide the coefficient, the 4, by the power. So the power is now going to be a 1, x to the power of 1, so you're dividing the 4 by the 1. And of course, if you do this, then 4 divided by 1 is 4, x to the power of 1 can be written as x. So the integral of 4 is 4x. And of course, we've got the plus c. Now, what does this actually mean? So let's say we've got a graph, we've got a y-axis and an x-axis. So if we said that the 4 represented y equals 4, then we'd have this line. So what does the 3 and the 0 mean? Well, the 3 and the 0 means on that line, we'll look at 0 and we want to look at 3. And what we want to do is, at 0 and 3, we'll look down to the x-axis and we want the area in between 0 and 3. That's what this means. So when you integrate a number, if you imagine that it's a line, y equals 4, then the integral will give you the area in between the numbers shown. If there are no numbers, it's just a general expression for the area, then the numbers tell you which parts to look at. So what do we do next? So we are going to substitute the 3 and the 0 into our integrated formula. And we do it like this. So first, we're going to substitute in the 3. So we've got 4x plus c. That's 4 times 3 plus c. And then, to find the area, we need to take away the other side. So we're going to look at the 0 next. That's going to be 4 times 0 plus the c. And if we work this out, then we're going to get the area in between those 2 points. So we do 4 times 3 is going to give us 12. So we have 12 plus c. Then we're going to take away 4 times 0 is 0. So we're taking away 0. And then we've got the plus c. We're going to take that away as well. So if we collect like terms, something interesting happens. So we look at the numbers first. We've got the 12 and the minus 0. So altogether that's 12. That's fine. Then look at the c's. We've got a positive c and a negative c. So the c's cancel out. And so with the median questions, we actually put some effort into figuring out what number c was. And you can only do it in a situation where you have a coordinate as a clue. But we didn't bother for this question because the c is going to cancel out anyway. So now what we can do is we can say the final answer, the integral of 4 in between 3 and 0 is 12. And if you look at the little graph we did at the top, that makes sense because if you look at it, I've got the green shaded area. We can see it's got a width of 3 between 0 and 3. And it's got a height of 4, as 4 is the thing we were integrating. And so 4 times 3 is actually going to give us that 12. Now, this one's one where we can actually sketch out the graph to work it out. We're going to move on to ones in a moment where it's not going to be a straight line, and we're going to find the area underneath curves. So for our next question, again, we've got the kind of integration notation, the integral symbol and dx. So we're showing that, well, in between that is what we're integrating, and we've got the numbers. We're finding the area under the curve between 4 and negative 2. So the thing we're integrating is a 4x squared. So we can do that. We can take the x squared and we can increase the power by 1. So x squared becomes x cubed. And then we're going to take the coefficient on that, the 4, and divide it by the new power. We're going to divide it by the 3. So the integrated version is 4/3 x cubed, and of course it's plus c. So now we've done our first step. We now need to work out the area under the curve y equals 4x squared in between 4 and negative 2. So we substitute in both numbers. Start off with 4, start off with a larger number. So we've got 4/3, x is going to be 4, and it's cubed. And we're adding on c. We take that away from the second number, that was negative 2. So again, we're going to have 4/3. That's going to be multiplied by the negative 2, and it's going to be cubed, and we're adding c to it. So now we can just use our calculator to work out these numbers. So 4 to the power of 3 is going to give us 64, and then we want 4/3 of 64. 64 times 4 divided by 3. That's going to give us altogether 85 and a third, and we plus the c. Next, we'll substitute in negative 2. So negative 2 cubed should give you a negative 8. So negative 8 times the 4 divided by the 3. That's going to give a negative 10 and 2/3. We see that's negative. That's just what's inside the bracket, but we're taking the value of the bracket away. So that means it's going to be a double negative. We're actually adding on 10 and 2/3. And then we've got the positive c, and we'll take that away. That'll be negative c. So altogether, we've got 85 and a third plus 10 and 2/3. That's going to give us 96, and the c's are going to cancel out. So going back up to the top, the integral of 4x squared in between 4 and negative 2 is equal to 4/3 of x cubed plus c, which is equal to 96. Moving on to our next question. Now we can see with this one we've got two terms that we need to integrate. And just like differentiation, you can integrate multiple terms as long as they're separated by a plus or a minus. If it's something else, there might be some other rules to use. So just take one term at a time, so the 9x. So increase the power on the x. X to the power of 1 becomes x to the power of 2. And the 9 is going to be divided by the new power. Then do the same thing to the next term. So we have a 1. Increase the power on the x. If there isn't an x, write 1 in. And then divide the coefficient by the new power. So it's just going to be power 1. So we're going to get this. It's going to be plus c. We can rearrange this somewhat. So we can say, well, 9 divided by 2, that's going to give us 4.5. 1 divided by 1 is 1. And we can write just x rather than 1x. So we have integrated. So now what we need to do is do a substitution. Largest number first, we've got a 3. So we want 4.5 lots of 3 squared. Take away, now I've got another x, so that's just going to be minus 3. I could write in the c here, but we know the c's cancel out, so that's something you can leave off if you choose. Then we're going to substitute in the 2. So we've got 4.5 multiplied by 2. We're going to square it. Then we're going to take away, we're going to substitute in 2 again. So let's work out all these terms one by one. So firstly, we're going to use BIDMAS. We've got to do 3 squared first to get 9, and then multiply it by 4.5. That's going to give us 40.5, 40.5. Then we're taking away 3, so nothing to do there. Then we're moving on to our second bracket. So we've got 2 squared is 4. Multiplying that by 4.5. That's going to give us 18, but remember we're taking the second bracket away. It's going to be take away 18. Then we've got the minus 2. Remember we're taking away, so we're going to take away negative 2. That's going to cancel out and give us a positive 2. We'll pop all that into our calculator to get our final answer. So 40.3 minus 3 minus 18 plus 2. Altogether, that's going to give us, we get 21 from the whole numbers, and we have the half as well. So the answer is 21 and a half. So we can go up to the top, and we can write 21 and a half in as our answer up there as well. Next, again, start off to identify the different bits of notation. We've got the integral notation. We've got the values we want to find in between, and we've got the expression we are integrating. Take one term at a time, 2x squared, increase the power from squared to cubed, and then divide the coefficient by the new power. So we get 2/3. Move on and do the same thing with the second one. So we've got 6x, increase the power from 1x to 2x, and then divide the coefficient by the new power. Remember that you add on c. And we can do a few things here to make this a bit easier to use. So 2/3 is fine, but 6/2, we can work that out. 6 divided by 2 is 3. So now we have integrated, we want to substitute. I'm going to start off by substituting the 2. So we have 2/3 of x, which is now 2, cubed. I'm going to add to that 3 multiplied by x, which is now 2, squared. And we can ignore the plus c's because they're going to cancel out anyway. Take away from that the smaller value, which is -1. So to substitute, we're going to have 2/3 of -1 cubed plus 3 lots of -1 squared. So we can work this out. So 2 cubed is going to give us 8. Then we can multiply that by 2 and divide by 3 for the fraction. And that's going to give us 5 1/3. For the next term, we've got 2 squared is 4. And multiply that by 3, which is going to give us 12. Moving on to the next bracket, so -1 cubed is going to give us -1. Multiply it by the 2, divide it by the 3, it also gives the same thing. It's going to give us a -2/3. However, because we're taking away a -2/3, we're actually going to be adding on 2/3. Then for last term, -1 squared will give us 1. 1 times 3 will give us 3. Remember, we're taking these values away, so we're going to be taking away the 3 at the end. We can look at the whole numbers first. 5 plus 12, take away 3, will give us 14. Then we can add on the 1/3 and the 2/3 to get 15 as our final answer. Then we can go up to the top and add that to our original kind of equation there. Our final question, now we've got 3 terms. So we can just have a look at the integral notation and the numbers of substituting, and we can see those 3 terms nice and clearly. Do each one at a time. So 7x squared, increase the power to cubed, and then divide the coefficient by the new power 3. The next one is -7x, to increase the power from 1 to 2, and then we've got the -7, so divide that by the new power 2. Then we've got the 4, increasing the power on the 4 is going to give us x to the power 1. And dividing 4 by 1 means we're keeping the 4. So essentially, if you integrate a whole number, it's just going to have an x on the end and nothing else will change. So now we have something we can substitute. You can change those 7/3, 7/2 into mixed numbers if you like. You don't need to. Depends on how confident you are with your calculator and which form is easiest for you. Start off the largest one first. We've got the 0. So we want 7/3 of 0 cubed. And that's going to give us 0, isn't it? Because, multiplying 0 gives you 0. The next bit, -7/2 multiplied by 0 squared. Again, this is one that's going to give us another 0. Then we're going to add on 4 multiplied by 0. So actually, the first bracket altogether is going to give us 0. So you might see that when you have kind of 0 or something to substitute, it's actually quite easy. So let's move on to the second part. Now here we're going to substitute in -3. So we've got 7/3 of -3 cubed, take away 7/2 of -3 squared, plus 4 lots of -3. And now we can work out those terms. So start with the powers. -3 cubed is going to give us a -27, multiply it by the 7 and divide it by the 3, the fraction, and altogether we get -63. However, we're taking the second bracket away, so we're going to take away -63, which will give us a +63. Then we're going to have -3 squared is 9, multiplied by the 7 and divided by the 2. That's going to give us 31.5. So it'll be a take away 31.5 in the brackets, but then we're taking away that on the inside as well. So altogether, that's going to be a +31.5. The final one, we've got 4 multiplied by -3, that's -12, but again, we're taking away negative 12, so actually we're adding that on. So surprisingly, all three terms in the second bracket that were taken away, they've all ended up being negative, so then they've all become positive, the double negative. So 31.5 plus 63 plus 12 altogether is going to give us 106.5. We can write that in our final answer. 106.5 is the area under the curve, 7x squared minus 7x plus 4, in between 0 and negative 3. And you'll see this quite often with negative numbers on graphs, where just because the area is in the kind of negative part of the graph, the negative part of the x-axis, doesn't mean that area doesn't exist. So you can get a positive area on the negative side of the graph as well.